Hello, everybody. Welcome back. It's Mo again. Well, in this lecture, we're going to be looking at this Class A network, right? So remember, we did Class C, we looked at Class B. Class C, the first three octets is a network, the last octet is a host. Class B, the first two octets is the network, and the last two octets is the host. So I have a lot of hosts, all right? Now, a Class A network, which means I'm going to start with from 1 to 127. Remember, we cannot use the 127 because that's a loopback. So 10.0.0.0. This is actually my network ID. And my broadcast is all 255s. See this? All 255s. This is the broadcast ID, right? So that's what I have. So what does that mean? I cannot put all zeros as an IP address. That tells me what network I'm on. I cannot put all 255s. That's the broadcast that I'm actually on. So let me go back over here and show you. So switching from one class to another, I'm going to do DHCP static 10.0.0.0. Got an error message. This is the network. All right. So I cannot use that. And if I put 10.255.255.255, this is a broadcast. I cannot put this as an IP address. Remember, the broadcast, which means if I send a message to that, is going to go to everybody on that network. So if I go back to here, what is my first host? 10.0.0.1. All right. Because I get three octets for the host. So 10.0.0.1 is my first host. So then it's going to be 10.0.0.2, 10.0.0.3, 10.0.0.255, then 10.0.1.0, 10.0.1.2, 10.0.1.255, then 10.0.2.0. And when this becomes a 255, then I go back 1.0.0 and so on. So the first octet is the network, and the last three octets is the actual host. So here, what is the last host? 10.255.255.254, right? This is the last host. Now, the number to the last host is the broadcast. The number after the network ID is the first host. So I have three octets for the host and only one octet for the network, right? So what does that mean? Well, my subnet mask is what? Let's go back and take a look. So watch this. So if I put 10.0.0.1, look at the mask. 1255000. See that? So I can put an IP address as 10. Let me just switch it. Switch over here, static 10.255.255.0. This is a valid number. The only time I cannot put a 255 here if these are 255s. See that? So let me save that and go back here. And here, 10.0.0.255. I can put this as an IP address as long as I'm putting a zero over here. That means it's the network ID. So this is actually good. Then let's say 10 dot a different number dot one dot one dot one. All right. And look at the mask 1255000 and 10 dot 2.2.2. And look at this 1255000. So as long as the first octet is the same on all the computers, that means they get all talk to each other. So look, 10, 10, 10, and what? And 10. And look at the mask. It's only a /8. What does that mean? Well, the subnet mask is 255.0.0.0. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's a /8. So 10.0.0.0/8. That's a CIDR. Only one 255, which means the first octet is a network and the last three octets is a host. So now I have 24 bits for the host. 2 to the power of 24 minus 2, which equals 16,677,214. If you're not sure, you get online and you check this out. Watch this. So I could say 2 to the power of 24, then I say minus 2, right? 2 to the 24, then I say minus 2. And what number do I get? There you go. See, it's like Google. I use it as a actual calculator. So I have a lot of hosts for a class A. So the first one has to match so all the computers can actually talk to each other. So if I go back And if I do an actual what? Envelope, which is ICMP, here to here, successful. Here to here, successful. Here to here, successful. So everything is success. Why? Because they belong to the same network. The first octet starts with the number 10. If I go back and I switch this to, let's say, 11, watch this, which means if the first octet doesn't match, that means they don't belong on the same network. They won't be able to talk to each other unless I have a router in between. So if I check envelope here, it's going to be a failure. All right. Again, let me check failure, and here is failure. And then here and here is actually success. They can belong to each other. And here to here is success. So the default mask for a class A is 255.0.0.0. It's a /8. That's the CIDR for a class A. So I have a lot of hosts. If I want to compare and do the 128, 64, 32, 16, 8, 4, 2, and 1. So I put 0 and all ones. All right. What number do I get? It starts with 1 because I know that a class A starts with the number 1 to 127. So 64 plus 32 is 96, 112, 120, 124, 126, 127. See that? So it goes from 1 to 127. That's why you have to remember the ranges. This is for a class A. Then remember we did the one for a class B, and then we did the one for a class what? A class C. That's how I could actually tell the actual ranges A, B, and actually C. As you see that? That's how I could actually tell. So class A gives you a lot of hosts. Why do I need these hosts? Well, when we talk about public and private IPs, we will see the difference. But for now, I want to understand the structure, the rules of class A, B, and C, the ones that I could assign on an actual system, right? So that's one thing to keep in mind. How can I assign on an actual computer? Right? So class A, B, and C are the only ones I could use internally. I cannot use D and E. In our next lecture, we will be focusing on class D and E and C. When can I actually use those actual IP addresses? All right. So we'll see you folks in our next lecture. Bye now. Okay.